Here are a few of the smells that you should look for in your code that could be indicators of a Liskov substitution principle violation. In this case, we've got something similar to this example we just showed, where we're iterating over a collection of a particular base type, in this case, employee, and now we're going to test to see if that employee is a manager, and if that's the case, we'll go ahead and call print manager. Otherwise, we'll call print employee. You can imagine that as we added additional classes of employees, we might have to further break up this if statement and add additional cases to it, thus making our code more and more difficult to maintain. It would be better if the manager knew how to print itself, or if the print manager were able to do the work within a single print method, regardless of which type the employee was, so that this if logic could be removed. Another smell that you'll find is if you have a child type that inherits from a base class or interface, but does not fully implement that interface. So in this case, we have an abstract base class called base, which has methods 1 and 2, and then we have this class child that's decided that it really only wants to implement method 2, and it's going to leave method 1 throwing an exception. This kind of thing is fairly common. It can cause issues if clients of your code are expecting you to have fully implemented the interface, and in fact you've only implemented it partially. If you control all of the code yourself, this may not be an issue in your case, but it is something to keep an eye on and be aware of. And it's something also that you might consider adding a unit test for, just to prove that you do in fact expect this not implemented exception, so that a user of your interface will, or your actual implementation, will know that that's expected behavior. Another thing that can help fix this kind of issue is if you follow the interface segregation principle, which we'll cover in a later episode. The interface segregation principle suggests that you use smaller, well-factored interfaces that are suited to the client code, rather than larger interfaces than necessary. And so if this were the case where, in fact, you only needed method 2 of this base class, you could refactor that base class so that it only gave you the methods that you needed, and specify an interface, either a base class or an actual C# interface type that would only include the methods and fields that you require. Let's look at how we can refactor our shape example in order to achieve a better design.